domain and restrictions. Domain and restrictions are two opposite ways of looking at the same idea, right? Domain is what values of x will work in this given function or relation, and restrictions are which ones don't work. Okay, does that make sense? So when you first meet functions, right, we have no need to think about this idea about domain or restrictions because the first kinds of functions that you meet don't have any domain or restriction problems, right? Like y equals x plus 3. You're like, I can just put in any numbers that I like and I'm just going to get values. Why would there ever be a problem? Okay? But it doesn't take very long to encounter functions that do have issues with, like, you can't just throw in any value that you like into x, right? What's the first one that you meet? Think about it. In terms of, I'm just thinking about domains, by the way. Just thinking about x's because they're more interesting, and the range just kind of comes from that. I'd kind of suggest very, very early on, even though you don't have this language, the first one you meet is this guy, right? Because you meet the square root of x as soon as you start doing Pythagoras, right? Now, you haven't really thought about functions and all that kind of thing, but, you know, everyone, once they get the calculator and they work out what the square root does, everyone tries to put in a negative underneath, and it's like, oh, it doesn't work. Now, all it means is there's no real value that corresponds to it. There is a value that does, but we're talking about real functions, aren't we? So in real functions, there's a domain restriction, okay? What's the domain restriction on this?
X is greater than 0.
X is greater than or equal to 0. I can take the square root of 0 and it's still a real number, 0. Okay? Now, there's a restriction. Then you keep going through all the different kinds of graphs that you learn, and you meet other ones, right? What might be the next one that you meet? I'd say 1 on x, the hyperbola, right? This guy's a problem, but it's not so much of a problem, right? There's only one value that breaks this guy, namely x is equal to 0. So therefore, I would say this or this, right? Everywhere except for 0, okay? Now, so far, there's one other main category of function that we've met that also has this problem of you can't just put in any value you like. We met it quite recently. What is it? It's these guys, right? Logs. If I say log base any constant of x, right? Where can this exist? Where can this exist? Good. It's x is greater than 0, not inclusive of the boundary. Not inclusive. Okay? And these are basically it. Like, these are your main categories. Okay? So for instance, if you see something like this, which is actually one of your questions. Right? How do you approach this thing? Now, this is a combination of these two guys, so you need to keep them both in mind. Okay? The first thing I would say is, let's just think about the square root. Let's just think about the square root, because before I get to the fraction, I have the square root first. Okay? So what I need is that what's underneath the square root, which is 2 minus x, right, that must be greater than or equal to 0. Does that make sense? Right? So that's just to take care of the square root. So what you're getting here is if you move that negative 2 over and then you divide, that's what you get. Are you happy with that? So there's the restriction according to the square root. Yep.
Shouldn't it just be greater than 0?
Okay, so one step at a time, I've dealt with the square root, but then I also need to notice it's a fraction. So not only can this thing, you know, not be, it's going to be less than, I can't even actually include the boundary value either, right? X can't equal 2. Because once you put that in, you're dividing by 0. This other kind of thing comes in, right? So therefore, x is less than 2 only, okay? So really, in terms of restrictions, there's only 3 categories you need to worry about, and sometimes it's a little complicated when you throw in more than one. If we really want it to be not very nice, we can go, you know, log base 2, you know, but it's actually not that bad because it's actually quite, like, they all fit together in a similar way. But these are the kinds of things you're going to meet and how they're combined, okay? So you can think about it purely algebraically if you like. Just keep in mind these guys, which hopefully as you graph will get into your brain.